Hey everyone, Miss Paraso here, and today's lesson is on estimating square roots of non-perfect squares. This is the handout that I'll be referring to. I'm going to do my work on a whiteboard, but I will be referring to these problems throughout, as well as these notes, and then pausing for some of those guided ones there. Okay, so let's go ahead and get started. The first thing that you want to know when you're estimating non-perfect squares, it's always helpful to have those perfect squares either committed to memory or just quickly write them down. So 1 squared is 1, then we have 4, 9, 16, 25, 36, 49, 64. See if I can fit them all on here. It's a little thicker than I thought. 81, 100. So usually the first 10 is pretty good. If you need to go higher, you can, but that should give you at least a good reference point. So from here, what you would want to do is, let's take a look at our first one. It's asking where on the number line should the square root of 22 go? Now notice all of these numbers are perfect squares. They do not have the square root sign on top of them. They are perfect squares because if I take the square root, it is an integer. So I'm looking to figure out where should I put the square root of 22. So the number underneath is not a perfect square, but I want to find a number that I could put there that is a perfect square. So I know 25 is larger than that, and then there's 16. So these two perfect squares are going to be on either side of it. So if I take the square root of 16, I know that's going to be 4. And if I take the square root of 25, I know that's going to be 5. So 22 is going to fall somewhere between 4 and 5. So I'm going to use my number line here. And right now, that's enough information. Like, okay, it's between 4 and 5. But what if we wanted to dive in a little bit deeper? So 4 squared is 16. And then we had our other perfect square here, 5. All right, what if, again, I'm trying to do all of this without really getting out a calculator, no guess and check. I want to be smart about this. So if I think about this, where does 22 fall? I'm looking at these numbers again. Is 22 closer to 25, or is it closer to 16, or is it halfway? Well, this distance, the distance between those two numbers is 3, and the distance between these two numbers is 6, so it's definitely past the halfway point, right? So if I had to make a guess, if this was the halfway point, this is 4.5, I would say the square root of 22 is probably around right there. But we could assign a decimal. This would help us narrow it down. And in just a minute, we're going to see how we can actually even make a better estimate than just there. But for now, that's good. We know it's between 4 and 5. So let's take a look at our next example. Now we have the square root of 57, but it's the negative square root. And so what I want you to do right now is I actually want you to just, let's ignore that negative sign, right? Let's put it off to the side here, okay? Let's focus on the 57. What perfect squares does this fall between? Okay, let's go up to our list and we can refer to it. Well, 57 is between 49 and 64. So I'm going to put 49 on one end and 64 on the other. So that means that it's somewhere between 7 and 8. Now, okay, but remember, it was a negative. So now that's where we want to think about the negatives. And if we think about it, I'm okay with this number line, it's being a little bit backwards, right? If these were negatives, I need to flip this around, right? Because technically, negative 7 would go there. Negative 8 would go there because the bigger the negative number. But ultimately, all you're really doing is you're finding out where in between these would go. And so that's technically what the number line would look like, okay? But for our sake, again, I'm going to go back to ignoring that for just a hot minute here. okay? And I really just want to focus on that square root, okay? All right, so the square root of 57, again, we know it's between 7 and 8. Can we dive in a little bit deeper? Well, how far apart are the 49 and 57? Well, that's a distance of 8, okay? And 57 and 64, that's a distance of 7. So it's just ever so slightly. So that's total 15. So 8 over 15, that's slightly over halfway there. So if this was 7.5, it's probably about right here, maybe around 7.6. But again, we took off that negative just so we could really focus on the square root. So all I would have to do is put that back in there. So it's approximately negative 7.6. Okay. So go ahead and pause the video. If you haven't already done numbers 3 and 4, go ahead and pause the video right now, and then let's check back in. Okay, so I went ahead and did both examples on the same page here just to kind of save some time. So we can see that 85 is between the perfect squares of 81 and 100. So their square roots would be between 9 and 10. And then if we take a look at the distance 85 is from our first perfect square to the second, we can see it's very, very close to 81. So I would even guess that it's probably around there, around 9.1 or 9.2, if I had to make a guess. Okay, so that helps me narrow down that one. All right, and then on the next one, again, it has that negative sign, but I ignored the negative sign for now. And I took a look. Okay, well, the square root of 25, that's 5, and the square root of 6 is 6. But it's going to be between negative 5 and negative 6, right? And then we can see that it's past the 25, about 5, so not quite halfway. And it's just a little bit further from the 36. So it's probably, I had to make a guess, like right here. It's not quite past that halfway point. So I would put that, and again, we'd want to know that those are our negatives. I know that this disclaimer, the negative numbers do not go this way. I'm just really helping you to see that it's just falling between those two numbers. Okay, so it's between negative 5 and 6, but it's closer to that negative 5. So that's how you could use that to kind of estimate just between what two integers, so that's like what two integers is the square root between, right? These are the perfect squares. We'd have to take their root to find out which ones is it in between. All right, but I'm wondering if we could get a little bit closer with our estimate. And we're going to use the same idea here, except we're going to take it a step further. So let's go back to the square root of 57. It was negative, but we're just going to focus on the positive one. Okay, so in number 2, the square root of 57, that was between, if we go back up to our list, it's between the square root of 49, and it's between the square root of 64. So I want you to think about it as you're starting, where's the starting perfect square? How far are you traveling to get to the next perfect square? But you don't quite make it. You get tired along the way. So the journey from perfect square 49 to 64 is a total of 15 steps, if you want to think about it that way. Okay? So our number here, the square root of 57, started off at 7. So it started off at 7, and it started walking. You know, the square root of 49, it starts walking, and it's like, oh, it needs a potty break. So from 49 to the spot I got to 57, that was 8 steps. It's gone 8 out of the 15 steps to the next perfect square. So we have taken an irrational number and turned it rational. So this is just an estimate, and we're just trying to make it a more accurate estimate than kind of like, well, I think it's about 7.5. So now if I wanted to get even closer and estimate to the nearest tenth, I can take this fraction and turn it into a decimal by dividing the numerator divided by the denominator. So I'm going to do my messy math off to the side. I'm going to divide my numerator, put a couple decimal points there, and I just need to go to the tenths, so that means I'm going to go out to the hundredths to check for rounding. And I'm dividing by 15. So 15 doesn't go into 8, obviously, because we have a fraction. If you get a whole number there, something's wrong. So 15 goes into 80 5 times. So that's 75. Bring down that 0. 15 goes into 50 3 times, and that's 45. And we can actually see that that's going to start repeating, right? But we're going to, so this is really 7 and 8/15 is the same as 7.53 repeating. And so approximately 7.5. So when we were doing that, we got pretty close. I think, what did we originally say? I think we had said 7.6 maybe. So that's how you're going to estimate non-perfect squares. So what I'd like you to do right now is on your paper, you have to estimate the square root of 11. So pause the video, see if you can estimate it, write it as a fraction, and then turn that fraction into a decimal rounded to the nearest hundredth. And when you're ready to check your work, go ahead and unpause and see how you did. All right. So you should have gotten for your answer 3 2/7, which is approximately 3.3. And if you had 3.2, just check your rounding because it's 3.28, and that 8 would round the tenths up to a 3. So again, it's between the perfect square 9 and the perfect square of 16, and that has a total distance. So between two squares was a distance of 7. And the square root of 11 only made it 2 steps out of the whole 7. So that's how we got 3 2/7 there. And then I divided 2 by 7 to get 3.3. All right? So go ahead and pause the video and try to do number 2 and 3 on your own. When you come back, I'll reveal my answers. All right, and we're back. So here we go for those last two. How did you do? As fraction form, it would have been -4 8/9. And depending on how you wrote it, if you noticed that it was a repeating decimal, I would accept that -4.8 as long as you had the repeating sign. If you weren't going to put the repeating sign, you do have to round it to the nearest tenth, which would be to the 9/10. Okay? Again, just because, don't forget, make sure you don't drop that negative sign when you're finding what perfect squares. So you can see that I kept the negative. Yeah, it's not in the right direction of the number line. That's okay. Right? And the same thing for 54. 54 is between 49 and 64. It had a total of 15 steps to get to the next perfect square, but it only made it 5 steps out of that 15. So again, this case it was 7 5/15. If you simplified it, which I should have simplified it, be 7 1/3, or 7.3 repeating, or if you didn't put the repeating bar, just 7.3. So that's how you estimate non-perfect squares to the nearest tenth using the fraction method, and not just a guess and check, using a little bit more precision with the idea of fractions. If you have any questions, feel free to message me and let me know.